This is lesson 6.4 on completing the square. Now in the past couple lessons we have been told to solve the equation so everything is set equal to 0. So we would, in this case, move the 64 to the left side. But we're going to do something else before we worry about that. We're going to show a situation that we have here and the perks of that situation. On the left we have a trinomial, and it actually is factorable. And we're going to factor it, and when we do so, what we find is that we will have x and x, plus and plus, factors of 49 that add up to 14, 7 and 7. Now we have a perfect square. X plus 7 times x plus 7. Now when that happens, that's actually a very good sign because we can rewrite it as x plus 7 quantity squared. Now this is pretty powerful when it comes to solving, because now we can go back to our basic solving with the square root property. That would give us x plus 7 equals a plus minus 8. So we would subtract 7 and finish with x equal to negative 7 plus or minus 8, which means two different answers. It means negative 7 plus 8, and it means negative 7 minus 8. So our two solutions are 1 and negative 15. Now we couldn't have done it that way if we didn't have perfect squares on the left side, where we could rewrite as x plus 7 quantity squared. So in this case it did not help us to move the 64 to the left side. It was actually better off to be kept on the right side. Now let's take a look at another example. Same situation here. We're going to keep the 12 over on the right side. And we have x, minus, minus, minus plus is a minus, minus, 5 and 5. Again, we have the same thing written twice as a product, so you can write it as x minus 5 quantity squared, which allows us to use the square root property. Remember that when we square root, to get rid of a square, we have a plus minus. We add 5 to both sides. We get x equal to 5 plus or minus square root 12. Now this is somewhat okay. The root 12 can be simplified. If we simplify that, we would get 5 plus or minus, and 12 is the same as 4 times 3. Which we can separate into their own roots, and we will get 2 root 3. Because of the square root that remains, it's called an irrational solution. Now completing the square, we can do basically what we've done in the last two examples if we have a perfect square. And there's a way to create a perfect square, which will then allow us to use that method. And it's a fairly simple process. Right now we have x squared plus 16x, and they're wondering what we will add that will allow us to have a perfect square. And the process is to take the b term, or the x coefficient, dividing it by 2, always dividing by 2, and squaring the result. This would give us 8 squared, in other words 64. 64 is the number that we would use to create a perfect square. What does that mean? Well, if we factor this, we should get the same thing in both parentheses. Factors of 64 that add up to 16, 8 and 8. At this point, I'll add in what I've learned from other YouTube videos and some very good input in lessons about this. And that is that we divide by 2 because these two terms have to add up 16 if we go through the FOIL method. And we square it because these two terms, when multiplied, have to give you 64. So those two components must be satisfied in order for it to be factorable. Hence we divide by 2 to satisfy the first part, and we square it to satisfy the second part. And this is a perfect square. So the number that would complete this and make it a perfect square is 64. Now let's try it with this one. Now, as of right now, I believe it is factorable. Plus minus, and we get factors of 12 that have a difference of 4. When we do that, and we get 6 and 2. Well, that's fine, but it's not a perfect square. In other words, we could not go any further with this at this point, except for to say, well, we do have a solution of negative 6 and 2, and that's fine. All right, and that does give us the solution. We're going to use this simple question, okay, and complete the square and see if we still get the right answer. Most trinomials are not factorable, just something to think about, so we want to be able to handle every situation. So we take x squared plus 4x, we're going to add something that will complete the square. Now there's a different way of approaching this. I'm going to choose to move the 12 to the right side to get it out of the way. Now to complete the square, I take the x coefficient, or b, divide by 2 and square it. Four is our number. Now if you remember, an equation is a teeter-totter. It's a balance, and I just added 4 to one side. I am not balanced. I must add 4 to the other side as well in order to stay balanced. Now this is an okay thing to do to an equation. It's legal, so to speak, because I did it to both sides. Now the benefit now is that if I factor it, I have 16 on the right side now. I will have the same thing in both parentheses, which will allow me to write it as one binomial squared. I will then square root, which will give me x plus 2 equals a plus minus 4. I'll subtract 2. We'll have negative 2 plus or minus 4, which has two solutions. Negative 2 plus 4, which is 2, and negative 2 minus 4, which is negative 6. The same solutions we got when it was factorable. I'm going to stop here, and I'll finish the next couple questions on part B.